Hi, this is Shannon Hilbert, and welcome to the BitWeenie video series on Xilinx System Generator. This video is the second in a series of videos and will cover how to start the System Generator workspace and then create and set up a new design. So the first thing we want to do is start the System Generator workspace. For best results, you should start the Xilinx tool from the Xilinx menu. So go to All Programs, find where you've installed the Xilinx ISE Design Suite, go to System Generator, and then start System Generator. If you start Xilinx System Generator from any other method, such as maybe MATLAB, just starting MATLAB directly or Simulink directly, you're bound to run into some problems because, as you can see as this comes up, over in this area it says it's initializing. So it's setting up some variables in the workspace that helps System Generator create its own design flow. So you'll see what's opened up here is just the typical MATLAB and Simulink environment. If you look a little closer though, you'll notice that we have some new block sets. We've got a couple different Xilinx block sets, and we'll be spending most of our time in this Xilinx block set here and the sub block sets here. But before we get started looking through the Xilinx block set and looking at the different blocks we can lay down, let's talk about how to start the design. We're going to want to start a design in an MDL file, which is a typical Simulink design. So you'll take the same steps that you usually use to open up a new Simulink design. Go to File, New, Model. What opens up is a blank Simulink design. So the first thing we'll do is just start off by saving the file. So go to File, Save, and let's name it Simple Gain. This is going to be a circuit that we'll use for the next several videos. So now that we have our file saved, let's go ahead and open the model properties and look at some of the options we have. So if you go to Preferences, you'll see down here Solver. Now this isn't 100% necessary, but I will typically set the solver type to fixed step and solver discrete. And I do that because what we're doing here is building a FPGA system which is inherently a fixed step discrete time system, so it only makes sense to use a discrete fixed step solver. You can use the ordinary differential equation solver that comes up by default, but sometimes you will get warning messages in the MATLAB window. Now I've previously selected the fixed step and discrete solver types, and so I don't need to do anything here. So I'll just go ahead and close this window. So now that we're all set up, let's take a look at some of the Xilinx Blockset options that we have. So I'll spend most of my time in Basic Elements Blockset for most of these tutorials, but there's a lot of good stuff in here that you can explore on your own. So the things that I want to talk about in particular is this basic element set includes things like constant, which is just obviously a constant, scalar or fixed point decimal number. The gateways in and out, which is the boundary of your FPGA design. Some logical functions and a multiplexer, registers for delays, and I'll probably take some extra time later to go over this reinterpret and cast block. The most important thing in getting our design started, though, is to lay down the System Generator token. So that's in the Basic Elements block set. You scroll up to the top and you see the System Generator token. Just drag it into the file and drop it. And this is where we can set up all of our model properties with regards to the FPGA. So double-clicking to open, I can select my compilation method, the part number, so the FPGA, and the synthesis tool. So for instance, if I am using Simplicity instead of XST, I use XST, but you can see you can use Simplify Pro as well as a synthesis tool. You can choose VHDL or Verilog as the synthesis language, but that's fairly transparent to you. You really don't need to know the VHDL or the Verilog. This is just here because this tool does in fact generate code, even though it may not be visible to you. And this is just an option to select that language you would like to use. So I'm going to choose Hardware COSIM for the purposes of demonstration later in a video tutorial system. I'm going to use point-to-point Ethernet. So going up to the clocking tab, there's a couple options that are worth talking about. Because I've selected the ML605 development kit as my hardware target, there's a couple of these options here that I can't play with. But if I was using a custom board or just wanted to target a particular part, all these options would be open to me. So this is where you can specify your clock speed, your system clock speed. And the Xilinx system period is where you can decide how many seconds of Xilinx time you want a clock cycle to represent. I always use a 1 because it makes sense. 1 clock cycle equals 1 second. Those are the most important options. There are some extra options here in general, but I'm not going to go into them. You can explore them on your own. Going back to the compilation screen, you can see the settings that we started out with. And there's nothing more here that we need to look at right now, so I'll go ahead and close it. Now we're set up and ready to start laying down blocks for our FPGA design. So taking a very brief tour of the block sets, let's go into basic elements. As I said before, the gateway in and the gateway out blocks form a boundary for our FPGA design. Almost every design will use one or more of these. Obviously, another typical and very useful block is a logical block. Let's just lay one down to see what it looks like to lay down a block. So here's an AND. And when I lay down an AND, maybe I don't want an AND, but this is just a logical block. So I can double click the block and up will pop a dialog screen, and I can change what function this is doing. And you should explore this on your own, but there's several tabs up here that will give you options. But for now, I'll just select I want to do an OR instead of an AND. And I want a latency of 2 clock cycles. And don't worry if you're not following along, because I'll do this later in more detail in a different tutorial. So that's an example of laying down a simple block. Let's take a look at some of the other block sets that are available. There's a communication block set where you can lay down block that represents IP that you would typically generate out of the IP core generator. For example, here I have a Reed-Solomon decoder, and instead of going through all the IP core stuff that we typically would in an HDL design, I can just lay down the block, and then when I double click, most of the options that are available to me in a typical IP core generator GUI are available to me here as well. So you can see I can customize that Reed-Solomon decoder block any number of ways using these tabs. So I'm going to go ahead and close that, and I'm going to delete this block. The Dsp section contains your typical DSP type things like DDS, chordic, to do trigonometric functions. The DSP48 block is available to lay down individually, so you don't have to just infer it through multipliers. You can lay down a DSP48A or E block or a macro, which are pretty useful to do very specific implementations of DSP48. Obviously, the math toolbox is one we use quite a bit. There's regular constant multipliers. There's also a variable multiplier, if I can find it. Here it is. You can see it just takes 2 inputs and 1 output, as you'd expect. And over here, while we're at it, this Z represents the delay. So that means that this Z to the -3 means that it will take 3 clock cycles to go through there. One of the last things I want to show you here is the wave scope, which can be very useful. If you're used to simulating in a regular HDL code, you may be wondering, how can I look at what's going on in my design as far as the bit transitions? And the wave scope is one way to do that. It's essentially, you can liken it to a model sim window. It works a little differently, but it's the same idea. So a wave scope is going to be basically like looking at your signals on an MSO. And we'll go into this block in quite a bit more detail in a later tutorial, but it's definitely beyond the scope of this one. So in this tutorial, we've covered how to get started with the Xilinx System Generator tool. We've learned that we need to create an MDL file just like a normal Simulink design flow, place a System Generator token, and then we can just place blocks out of Xilinx toolsets. Thanks for watching. Be sure to take a look at the preceding videos in this series at www.BitWeenie.com to better understand how to get the most out of System Generator design process. Thanks.